Okay, this is our talk on financing of sustainable or green real estate projects. It's chapter 8 in the real estate finance text. And let's jump right in with our introduction. First thing to know is that sustainable and green are synonymous. And so, what do we mean by a sustainable or a green real estate project? Well, like many things in this life, there is no single definition. What we will say for the purposes of this chapter is that sustainable projects are defined to include structures themselves, users, local habitat, and local to even global ecosystem around our project. Also, sustainable projects are going to consider not just economic issues, but also environmental and human health impacts of our project. And we want to measure all of these things over the project's entire life cycle, and that means design, build, manage, recycle. And then finally, green projects are going to be defined to include our aiming to achieve environmental and human health benefits while remaining economically competitive. Clearly, this is a much broader definition of what a real estate project is than anything we have encountered to date, and it's a much broader definition of a real estate project than has been traditionally considered in the industry. So let's compare and contrast traditional to sustainable projects, okay? If we look by project stage, which we often do, and we compare objectives for traditional projects and sustainable projects, we find in the design build phase, what's traditionally been looked at and what we've been looking at is trying to provide a great structure and minimize our construction cost. From a sustainable or green perspective, the aim is still to provide a great structure, but now to contain life cycle costs while remaining economically viable, optimizing our environmental impact, and maximizing user health and comfort. Similarly, with managing of project or operating cash flow producing property, traditionally we've been looking at providing great user experience and minimizing our operating costs so we can maximize our NOI, et cetera. So we want to do the same thing from a green perspective in terms of user experience. And now instead of minimizing operating costs, we're looking to contain operating costs while remaining viable economically. We want to optimize our environmental impact and we want to maximize, again, user health and comfort. And then finally, at our exit stage, which will be the recycling or disposal stage of the structure, we're aiming to maximize our sales price, what we can get for the land, the building, if it's going to be repurposed, etc. And from a green perspective, that typically changes to something like get a good sale price consistent with our other important green objectives, which are to maximize recycling, minimize damage to habitat around the building and the ecosystem around the building, minimize public health hazards that, as we all know, can happen from demolition, and et cetera. So we have a lot more going on with green projects than we had with traditional projects. The assumptions of sustainable projects are worth talking about a little bit. Underlying assumptions to green projects are that they should contribute to the public good. Okay, that's why we're not just maximizing our NOI, minimizing costs, et cetera. Also, that the public good is furthered by minimizing total energy use, minimizing habitat alteration, et cetera. And we don't accept the unquestioned preeminence of profit maximization. So it's a very, very different kind of perspective. The implications of this is that doing green buildings is going to be much more complicated than doing traditional projects. It's going to consider much more than a project's economics. It's going to involve significantly more constituencies and design specialties, as we'll see. And it may or may not have compelling free market economics, okay, which may not matter too much if you're a city building, a city hall building. You're very interested in the public good, much more so in some ways than the particular economics of building and operating a structure. Okay, Pat said an interesting feature of many sustainable projects is that free market economics over the life cycle of the project may be compelling, even for privately done green projects. Usually our upfront costs, design build costs, development costs are going to be higher than they would be with a traditional project, but this may be more than offset by lowered operating costs from things like energy savings, reduced water bills, reduced electric bills, et cetera, getting higher rents from better worker health and productivity. We'll look at some data on that farther on. And also getting higher rents from simply the prestige of saying you have a state-of-the-art design building. So what projects are a good fit for a sustainable approach? Well, and right up front, one that comes right to mind for me is owner-occupied types of buildings, as opposed to design, build, sell, something like CAG did with the Apex Apartments when they were developing it with the aim to sell it right away. If you're an owner-occupied building with something like an office building, a single-family home like your parents may have a mortgage on, a residential condominium or a co-op, in a case like that, even though the upfront costs might be more, you might be offsetting those because you're sticking around for a long time. And because it's yours, you may care more deeply about the environmental impact. Another type of project that's potentially a very good fit for a sustainable approach is all the sets of civic buildings and infrastructure projects. We may think of things like schools, churches, government buildings, roads, bridges, train lines, etc. Here again, the importance of contributing to the public good may trump a lot of other economic issues and considerations. So what's the corollary to that? What projects may be a bad fit for a sustainable approach? Well, if you've got a short-term ownership, something again like CAG getting into a project that they just want to flip very quickly, you're not going to realize any of the savings from having a high-performance building enclosure system or something like that. But you would pay an awful lot for that during the development of the project. So you might want to forego that and help increase your profit. Buildings occupied by short-term tenants, they don't want to make the investments in green technologies that may take many years to pay off. Speculative and non-prestigious projects. Prestigious projects more and more like to include a green component in their marketing or a sustainable component in their marketing. Clearly, this is not so, at least not right now, for lower market, less prestigious projects. Also, projects where the community lacks a consensus on what is the public good. I think you could say nationally right now in 2017, the United States as a whole, if you look across the country, has no national consensus on what does and does not contribute to the public good. And this can happen, of course, at a local level as well. So why do we care about green projects or sustainable projects? Well, I've already alluded to this notion of contributing to the public good, but let's look at some other things. If we consider buildings, for example, the environmental impact of the buildings that we inhabit through most of our lives is huge. Buildings are responsible for, in the United States and other developed countries, 1/6 of all our water usage, 1/4 of the entire world's wood harvest, 2/5 of our other material flows, and 2/5 of the world overall's energy usage. So buildings have a very, very big impact on the environment at local to global scale. The impact of buildings on human life and health is huge. Developed economy populations spend 80% of our time in buildings. Okay, so 80% of our time, you want it to be good. The quality of building environments has been shown to materially affect the health and performance of its occupants. For example, 20% of traditional building office workers may exhibit sick building syndrome based on surveys of office buildings in this country. Workers in high quality building environments with high quality lighting and HVAC systems have measurably higher productivity than those in poor environments based on studies done by Lawrence Livermore Labs and others. Also, sustainable buildings may increase return on investment for long-term tenants and owner-occupiers. What do we mean by increasing return on investment? Well, for us, the way it's been and the way it's going to be throughout your careers in finance, you get a higher NPV from increased productivity of workers. Okay, so there's a study done in 2003 that shows increase of NPV in $40 per square foot with a higher quality environment in office buildings, and the NPV of our operational energy efficiency from operational energy efficiency increases by, on average, similar study, about $6 a square foot. Okay, so the impacts are material and interesting, non-trivial. So what's going to be our framework for sustainable design? What are we going to use to be able to assert that we're following sustainable or green design practices, and how are we going to measure them? Well, in the US and around the world, the leading body that creates, promulgates, and manages and measures guidelines for sustainable design is the US Green Building Council, commonly called around the world USGBC. It is a nonprofit trade organization, and I think that's something to think 2 or 3 or 4 times about. Okay, a trade organization means that its members are made up of for-profit entities that are in the built environment business, real estate business, or something else related to the built environment. For example, GAF is a manufacturer of roofing systems. Nucor is a manufacturer of steel truss systems for buildings. Lennox, a very large HVAC provider. Kohler, very large water systems and water fixtures designer. Autodesk, design software. PPG, glass and enclosures. You get the idea. Okay, so all of these folks may have a big conflict of interest in actually creating, promulgating, managing the use of guidelines. And you could think about that a little bit as to why they might have a conflict of interest. So the USGBC created and maintains green building standards called LEED. Again, LEED standards are used throughout the world. LEED stands for Leadership in Energy and Environmental Design. This is a set of rating systems for designing, building, and operating green buildings and even neighborhoods. As I've indicated, LEED rating systems are the global standard. And again, they're established and specified by a set of large corporations who are in the built environment industry and whom I would argue have a vested interest in creating standards that promote the use of their systems, materials, and technologies, which I don't think is a good thing. That's just me. Welcome to your own opinion. Okay, so what are the lead categories for green design and building management and conversion, et cetera? First one, green building design and construction. It includes new construction, what they call core and shell, which we would call gut rehab, schools, retail, new construction, and again, gut rehab or major renovations, healthcare. Second, interior design and construction, commercial interiors, retail interiors. C, green building operation and maintenance across all building types. Green neighborhood development, green home design and construction. And they actually have a couple others, which you can look up on their website. Okay, they have a rating system for LEED, which applies to all of these categories. So if you're doing something in a given category, let's say building design and construction, new construction, the most points you could possibly get is 100 for this project. And you're going to get points by having potentially beneficial environmental impacts and human benefits as defined by this trade group of large for-profit companies in the built environment industry. Okay, so you can become certified for LEED by getting 40 to 49 points. That's very easy. You can get what's called silver status with more points, gold with more points, and platinum, which is as high as it goes with 80 points and above. So I'd like to go over with you just quickly. You can look at the details for this rating system for each of the categories that they have at the LEED website. And I want to just go over one of them with you now. Let's say you were doing a commercial construction project. Here's how you would rack up points on the LEED system. You have to meet anything that says prerequisite, and other than that, you just check what you've done. And it does get inspected, and of course, to be a LEED inspector, you have to be certified by LEED, and that brings more money to the USGBC, getting fees for people who are becoming certified, et cetera, and adds to the cost of the building to get this type of inspection. All right, enough of that. So the site selection, which is going to be, how do you know if you have a good site selection? Well, you got a LEED trained architect to make sure that you do. Development density and community connectivity. So the USGBC folks have some a priori ideas on what is appropriate density and community connectivity, and you have to fit yourself into that. Brownfield redevelopment, that's, I would argue, probably a good thing. You may disagree. Alternative transportation, public transportation access, et cetera, et cetera, et cetera. Site design, maximize open space. So they're presuming it's good to maximize open space. If you've walked through Greenwich Village, you might want to take issue with that. And you want to look at things like heat island effect, light pollution reduction, et cetera. Then you get more points for water efficiency. Probably almost everyone would agree that's a good thing. Water use reduction, water efficient landscaping, innovative wastewater technologies, water use reduction, that type of thing. I don't know why water use reduction is there twice. Anyway, have to look that up. Then you can get more points from an energy and atmosphere perspective. You're minimizing your energy performance, which probably everyone would agree on to a certain extent. Your refrigerant management, optimize your energy performance, on-site renewable energy. So they're presuming that's always a good thing. Maybe using natural gas might be better in some circumstances, but not as far as LEED is concerned. The measurement and verification and green power, I'm not sure how that differs from renewable energy. Materials and resources, building reuse, construction waste management, materials reuse, recycled content, which is, of course, going to make PPG very happy because they sell at a very high premium, recycled content, structural glazing for facades and things like that, regional materials, rapidly renewable materials, certified wood. How do you get your wood certified? Well, it gets certified by the USGBC by LEED trained experts. And in design, innovation in design, I should have pointed out that some of the country's largest architecture and structural and environmental engineering firms are part of the USGBC. So how do you get an innovative design? You get one of these fancy architecture firms and pay them a lot of money for their design in some way that they know it will be called innovative, and having LEED accredited professionals going through your whole design process. Then regional priority, et cetera, et cetera. I'm not going to go through every one of these, but my point here is that some of these things I think we could all agree on, and some of them seem to be subjective and arguable. There could be other perspectives on them, and I think that the perspectives that are put forth here are put forth by companies that have a vested interest in them by via selling their design services or selling their products or technologies. That's just me. Okay. All right, so let's look at some example LEED certified buildings here. Up on the top here, we have an environmental center in Newport Beach, California, and this has platinum certification, as high as it gets. And we have a Kansas Arts Center project down here, also platinum. You'll notice that both of these buildings are for high-end uses, and also you'll notice that both of them have a double glazed facade, which has, in my view, based on the physics, sort of marginal energy mitigation benefits, but definitely doubles the cost of the glazing, which again makes PPG and companies like that very happy. And also the architects that get to do a fancy design. Okay, what is the financial impact of LEED-based designs? Now we're bringing this right into real estate finance. The sources for everything I'm going to talk about in this section, I'm going to put in the readings section of classes, and they are mostly coming from performance of LEED design new buildings, CoStar study of 2008 and 2010. Okay, so in dollars per square foot basis, the extra costs in percentage to build green, this is for commercial structures. You can see for certified, it's about zero. For silver, about $1.50 extra per square foot compared to just traditional construction. Gold is going up to about $2, and platinum up to about $6.50. The certified, I think, is interesting because a lot of developers with luxury buildings, type A office buildings, they like to say they're LEED certified. If you go through carefully everything that's required to be just LEED certified, it's not much, and that's why it doesn't cost much. However, most people out in the real world don't know that, and LEED certified sounds good to them. So developers like to extol that, even though it doesn't really mean very much. Okay, so if we look at a national database of Class A office space, and we look at average rent for offices of 500,000 to 1 million square feet. These are big, big things. These are like buildings in Manhattan, that type of thing. You can see clearly the rent per square foot crashed in the Great Recession and continued going down after the end of the Great Recession. But the really interesting thing is that LEED buildings they had higher rents, Class A, top end of the commercial scale. They had higher rents to start with, and they maintained those higher rents through the Great Recession and beyond. So that's pretty interesting for you as prospective developers. Also, a word on the Energy Star system. The Energy Star system is a system very much like LEED that the Environmental Protection Agency tried to put together for folks to use instead of LEED. It never caught on, except with maybe a couple professors here at NYU and a few other places, but it's just not used very much out in the real world, and it never had much meaning to people renting commercial office spaces because you can see the rents obtained from Energy Star certified buildings are effectively exactly the same as traditional buildings. Okay, so in terms of exiting, looking at your sales price per square foot, if we compare non-LEED to LEED, you can see a very big difference before the Great Recession, and again, just before the Great Recession. Q1 2008, the Great Recession wasn't really going yet. It really got going in June through September of 2008. And the cap rates, if we look at 2010, cap rates for 2010 office sales for all sales 7.63%, and for lead sales 7.25%. And when you are a seller, of course, that's a good thing. You want whoever is coming in to get a very low cap rate. Yeah, there we go. Okay, now let's look at what's called energy use intensity, which is measured in thousands of BTUs per square foot per year. So if we look at average US commercial buildings energy use intensity, national average is 91,000 BTUs per square foot per year. LEED certified buildings, a lot less, 67, and for LEED gold, a lot less than that, almost just 50% of the national average. This is interesting. It might be better to use cubic feet instead of square feet, which would account for double height spaces, tall ceilings, things like that. Anyway, let's not quibble. Okay, so let's talk a little bit though about issues with using some of these average data points. If we look at this graph of design energy use intensity as opposed to measured energy use intensity, we see there's a lot of spread, and someone may claim they have really, really great energy use intensity, where in fact we're only getting about 50% of that in the real world. And also, if we look here at the proposed savings of buildings, and we have this broken into certified silver and gold, versus actual what happened when the building really existed, okay? If we were here on this line, above this line, we'd be doing well. And this down here is horrible. So what does it mean if we're down below the zero? It means if we take this building, for example, here's a certified building. It was claiming it was going to have energy savings over traditional construction of about 45%, okay? And in fact, it was worse than a traditional, oh, I'm sorry, it was proposing that it was going to have savings of about 20%. And it turned out when they measured it, they came in and measured it afterwards, it had much higher usage than a traditional building would have had. So these average numbers are not good. You've always got to look at the spread. And the other thing that I would say is that a lot of times proposed LEED items do not get measured afterwards, and a lot can happen between the lip and the cup. And if a building is not constructed properly, even though it's supposed to have great savings, it might not, okay? Just very, very, very simple example. Convective losses, drafts coming in and out of buildings are probably the biggest single loss for most residential buildings and most pre-1980 multifamily rental buildings. So if something like this doesn't happen, you're going to have very big convective losses, and your actual performance of your building is going to be nothing like what you claim in your design that it should be. Same sort of thing here. You could use either this or this to get your solution here. So here's an example where we have, this is the treated air coming in, and this is actually a return. So stupid things like this happen. So the conditioned air, which is of course also heated and cooled as well as controlled for humidity, never gets into the occupiable space. It just gets pumped in and goes right out the exit. Also here we see an example, this foil-faced insulation. To provide the insulation that it claims it does, it needs to have the foil on an airspace facing the inside. And so you see that's not done consistently here. So a lot of things like that can happen in the real world to make the actual performance of your building much less than your mechanical engineer, your HVAC engineer is going to claim. Okay, here's another thing which is pretty interesting and useful. It shows users' perceptions of building performance, okay? And red is the average of all the buildings in the BUI database, and green is data points from a set of LEED certified buildings. And I like this graph a lot because it shows you all the data points, not just the average for the LEED certified buildings. Okay, so as far as acoustics, you see big spread with acoustics, but not really much change over the average. In terms of lighting, looks to me like a very clear benefit here. To LEED, the average would be something like that, but clear benefit to LEED. With temperature, I'd say we have something like the average here, probably not a statistically significant difference. With air quality clearly a very big benefit. All the data points are above the BUI average, and the expected value is well above that BUI average. Helps getting work done? I don't think so. And overall satisfaction looks to me like there definitely is some overall satisfaction. It may be from the placebo effect, it may not, but nonetheless, it's there, some overall satisfaction from LEED certified buildings. Okay, so next up, what we want to do is consider the economic value of LEED-based designs. And we want to be able to do DCF-based valuation of LEED-based design, just as we have done for traditional design, build, sell, and manage and sell properties. And even we haven't done yet, but we're about to design, build, manage, sell properties. So what are we going to do? We're going to use the NPV method. We're going to get, for the sponsor, the net comprehensive cash flows for the whole project, design, build, manage for a number of years, and then recycle the property or sell the property, something like that. And our approach is going to be that we will go ahead and get an NPV for LEED and an NPV for traditional construction. And then we're just going to subtract the NPV for traditional construction from the LEED NPV, and that'll be our delta NPV. And that'll be potentially a big selling point for doing this project. Again, this is going to work best for folks who want to design, build, and manage and operate a building for some time. So that's the type of project we're going to look at. And I think this is a good place to stop, and we will pick up with this very interesting quantitative analysis in our next session. So see you soon.